Welcome to your break from Trig. So, we are going to do a little mini chapter on statistics. You need your packet, your note packet, and you need your calculator. So, I am going to try to be as brief as I can be. So, you're going to maybe want to jot more down than what I write because I'm not going to take the time to write a lot. Statistics, here's a definition right here. It's a pretty good one as far as I'm concerned. Collection, organization, analyzing, interpretation of quantitative. That means numerical, quantitative, and you might want to just do some underlining for the places where the writing is on the paper to draw conclusions and apply them. Okay, so we have different ways we collect this data that we're going to analyze. So one of the ways is a survey. It could be some sort of a questionnaire. That might be, say, we're going to get some kind of new food in the cafeteria. Maybe every student gets a questionnaire asking on their favorite types of sandwiches or something. A poll, sometimes polls are taken to determine who people are going to vote for. Okay, there's another way we can get data, and that's by observation. And so basically, in this case, we have data that we look at, but not influenced. So usually this is data that's already occurred. Perhaps it's like last year's Algebra Trig Regent scores or something like that, and someone's going to take a look at them and figure out what the mean is or do some other calculations and analysis. But we don't move them, we don't change the data. Okay, a controlled experiment then is when we actually go in and say, hey, we're going to do an experiment to get some information. And just a couple of things that I think you've probably met in science class. When we do an experiment, we often have a control group, an experimental group. Whoops, experimental. Let's see if I can spell that word right. Experimental group. And so usually we have some kind of thing we're trying to look at. Probably a good example I can use here would be, say we're going to test some kind of a new drug, like something to cure headaches, for instance. And so they create some kind of new drug that's going to do this, and so they decide they're going to have an experiment, and in order to make sure that it's actually the drug that's causing the improvement in the headaches, they'll have a control group, and the control group is often given what's called a placebo, and the placebo is a sugar pill, as in it's not the actual new drug, but the people in the control group don't know they're in that group, and the experimental group is getting the new drug. And the results are analyzed to try to determine, like, does this new drug actually work? As opposed to do people just think it works because they're taking something that they think is going to cure a headache. Okay, now, the main thing that we need to care about, or one of the main things we need to care about in statistics is that we have good studies, that we have good data to analyze. And so we're normally looking to analyze data about a population. So the population is usually big, and it's usually not possible for us to actually get data from every single person or thing in the population. So we usually take a sample. So if you can imagine, like, if the population we were concerned about was, say, like New York State, it's very difficult to survey every single person in New York State, plus it's expensive. So we take a sample. So, the main thing about taking a sample where we're going to get fewer people is we want to do what we call prevent bias. And so when we get our sample, we want to make sure that we have not done something so that we're getting only a certain type of person in our sample, or only people that have a certain opinion or a certain characteristic. So there's a couple ways that we prevent bias, and the two main ways is we really control our study. So we try to keep outside factors out of the study that are going to bias our results. And we're always trying to actually have our results, we want to prevent the bias so that our results don't skew what we think about the whole population. The other main way that we prevent bias is by making sure that our sample is randomly selected. So we want to be careful that if we're doing a study on, I don't know, say it was a study in Ellicottville and it was a study about something to do with Holiday Valley. and it was going to cost the town some money to do it, we want to be careful that we're not taking a sample just of people who are skiing or snowboarding at Holiday Valley, because they may have a tendency to say, oh yeah, do it, whereas the rest of the people in town may not. So there's different ways to get a random sample. Sometimes we will create a list and say, hey, every 20th person on the list we're going to survey. That's one technique. There's some other techniques that are not real important here, but you can learn more about if you decide to take stats down the road. So there is an example here. You can stop the video and read it if you like, but basically it's about taking a sample of students at a university. And the question is, how many hours do you study each week? And so the decision is made to survey every 10th student that goes into the library. And it turns out these students, the average is 15.7 hours per week. So, question is, which characteristic of the survey could create bias? Is it the size of the sample, the size of the population, the method of analyzing the data, or the method of choosing the students who were surveyed? So this is a really good example of bias, because the reality is, if you're going to pick your sample from students going to the library, then they more than likely are spending more time studying than other students who are not in the library. So this is a situation where the method is the problem. Okay, so next section is old news, so I'm not going to spend a lot of time on the old ways of doing this. I want to introduce more new ways with our calculator. So these are things you've seen since middle school, if not before. You can read through. What is a mean? What is a median? Remember, mean is also called the average. Median is the middle of our data. You want to remember how to find the median by hand. When there's an odd amount of data, there will be an exact middle number. An even amount of data, you're going to take the average of the two numbers in the middle. And the mode then is the number that we see the most. And it's possible that we may have more than one mode if there's a couple numbers we see the same number of times, or we may have no mode if there's no repeats in our numbers. So down below here are some calculator steps, which I'm going to talk about in a second. But let's go up here and take a look at this information in this example. So basically we have an example. We have some values, in this case 8, 10, and 14, and instead of listing them a bunch of times, we're told we have 1 8, we have 3 10s, and we have 2 14s. And we have to do something to kind of compare the mean, the median, and the mode. So without any fancy graphing calculator to do the mean, we'd have to say, oh, we got 1 8, we've got 3 10s, and we've got 2 14s. And we go through this process, we'd add them up, and we divide them by the number of numbers we have, which is 6, and we would determine there to be 11. Okay, then to do it by hand to find the median, we'd have to go through the process of saying, well, what number's in the middle? If I just look back up here at my listing, I can see that I have the 2 10s are in the middle, so the average of 10 and 10 is 10. And the mode then, if I look at my list of numbers, would also be 10. So now, in order to answer this question, we do a little bit of comparison, and I think, let's see, is the mean equal to the median? Mean equal to the median? No, that's not the case. Is the mean greater than the median? Yes, that is the case. So double check here. Is the mean less than the mode? Nope. Is the median greater than the mode? Nope. Okay, so I think you could do this problem before I'm about to talk to you about how to do it in our calc, but we want to be able to do bigger pieces of data, more data, analyze, and have a calculator to help us. So some of you may have seen this before, but I want to go ahead and review. So if we're going to use our calculator to do this, we want to actually go to hit the stat button, and we're going to hit edit. And it's possible you have stuff in your list, so I'm going to go ahead and clear my list. So I've just gotten up on the L2 and hit clear. Now I'm going to go over here to L1 and I'm going to hit clear, and it'll just clear my list for me. Now, do not hit delete when you're on your list, because it'll take the column away, which we can get back, but it would be better not to have that happen. So one thing we could do is we could just put the numbers in and say, okay, I've got 1 8, I've got 3 10s, and I've got 2 14s. And the calc steps are down on the bottom of your paper, so that might be a good reference for you. If I now hit my stat button and I go to my right and I hit calc and hit enter for one variable statistics, now this is a TI-84, and so if you have a TI-84, you're going to see it's going to ask you for your list, and then it's going to ask you for your frequency. And if there's anything there, you want to hit clear and come down here and calculate. If you're on the TI-83 Plus, it'll just go to your main screen and you're going to hit enter. So I'm going to hit enter, and you'll notice that this thing here says X bar. That's what we call that, and that is the mean. So that's where you're going to find your mean, same as what we saw before. And now I'm going to scroll down. There's other things on the screen we'll be interested in later, but not right now. And if I want to find my median, it is sitting down here. This is my median. Okay, so that's one way to do it, but I want to show you another way to do it. If I go back here and I hit my stat and my edit, and just for practice I'm going to get up on my list one there, hit clear, hit enter. And if I instead put in exactly the table that I see on my paper, I put in an 8 and I tell my calculator there's one of those, you'll notice you got to be a little careful, because when I hit 10 for the second one, it drops down below, and if I really want to get over to the right, then I need to arrow over there. There's 3 10s, and then I'm going to say, hey, calculator, there are 2 14s. Now, in this problem, it's not that big of a deal. There's not that many numbers. But if there was like 25 14s and 300 10s, you don't want to have to write them so many times. So this is pretty convenient. So I'm going to do the same thing again. I'm going to hit stat. I'm going to go to calc. I'm going to hit enter for one variable statistics. My list is still L1, but my frequency list, as in how many of each of these I have, is in L2. So I'm going to hit second 2 for L2. And I'm going to drop down here and hit calculate and hit enter. And I get the same values. Now, if you have a TI-83 Plus, what's going to happen is when you go ahead and hit stat and you hit calc and you hit enter at this point, you're going to go to your main screen, and then you're going to have to type in L1, comma L2 by hitting second 1, comma second 2 to tell your calc, hey, this time I have frequency values in list 2. This comes in very handy when we have lots of data. So, to just go back here, if you take a look at the bottom here, this is a pretty good reference, I think, to kind of tell you what buttons to push if you're doing this and you forgot how to do it. Okay, so that is what we call talking about the central part of the data. Central as in the mean talks about the middle of the data. The median talks about the middle of the data. So now we want to talk about what's called measures of dispersion. And dispersion is like when something is dispersed. It means it's sort of like how spread out is it? And so when we're really trying to analyze data, just looking at the middle really isn't very helpful. We want to actually look at how spread out our data is. So, something you've seen for a while is called the range. Range, basically, you just take your max minus your min. Now, back in middle school, this maybe was useful, but if you want to actually get a little more sophisticated, it's not that useful, especially in the example we have here. They're talking about a company. There's a CEO, the head person, makes $5 million. The lowest paid person, the janitor, makes $25,000. The range is almost $5 million. So it makes it seem like, oh my gosh, look at this company, what the range of amount of money people make. But in reality, these are really one really high number and really, really low. So it might not be telling us what we want to know about our data. So that's where we can get a little bit more specific, and we're going to talk about quartiles. Now quartiles come off what we were just talking about, which is the median. So I'm going to start here and label my median. So in reality, the median is what we call quartile 2. So 50% of the data is below it and 50% of the data is above it. Well, if I go to the middle of the lower half of the data, we call that quartile 1. So in this case, then, I've got 25% of the data is going to be less and 75% is going to be higher. If I come over here to the median of the upper part of my data, this is called quartile 3. And so quartile 3 then is going to be 75% of the data will be below that. So this kind of helps us get a little bit more interested in sort of like forgetting about the guy who makes $5 million and the person who makes $25,000, because we're going to start kind of looking a little tighter in and not let the high and the low affect us so much. Which leads us to, instead of the range, something called the interquartile range. And the interquartile range is also often called the IQR. And basically what the IQR is, we take quartile 3 value and we subtract the quartile 1 value. So it's really kind of talking about the middle 50% of the data. And what it does is it eliminates those things called outliers. And by eliminating the outliers, we can not have to be affected by the really high numbers, the really low numbers. So we already had this on our screen, we just didn't talk about it. Here, let's take a look at another example. So Conant High School has 17 students, championship bowling team. Each student bowled one game. Here are the scores in the accompanying table. So once again, rather than writing like 144 times, 145 3 times, we have the scores in one table and the frequencies in the other to make it easier on us. So our job is to find the range, the lower quartile, also known as quartile 1, the median, the upper quartile, also known as quartile 3, and the interquartile range, the IQR, which we just talked about. Now, the range, we actually do need to use our brain because our calc's not going to tell us what the range is. So if the high score was 194 and the low was 140, then our range would be 54. So now let's get our calculator to help us with the rest of this. So I'm going to go ahead and bring up my calculator. I'm going to hit Stat, Enter, and I'm going to go ahead and clear my list. Now another thing you could do is if you're right on the actual values, you can hit Delete to make them go away. I've just sort of gotten in the habit personally of getting on top of the name of the list, list 1, hit the clear button, hit Enter, and they all go away. So I'm going to go ahead, I'm going to type these in. 140, Enter. 145, Enter. And I would just suggest one other thing as I'm thinking about it, as I'm doing it. It's really a good idea to scroll back through and double check that you put your numbers in correctly, because your data and your analysis is only as good as what you've put into your calculator. So I think I've done that correctly. And now I'm going to go on down this list and do the same thing, hopefully getting these numbers in. And I'm going to scroll on up, make sure I got all the right numbers. 1, 2, 2, 3, 2, 3, 4. Okay, so now I'm going to hit the clear button again here so you can see what I'm doing. I'm going to go ahead, I'm going to hit Stat, Calc, one variable statistics, and I'm in business here because I've got L1 and L2 already on my screen. Those of you with the TI-83, but when you hit Enter, you're on your main screen and you have to put in L1, L2. I'm going to hit Calculate. So, the things that I care about for this problem are the lower quartile, the median, the upper quartile, and the interquartile range. So I don't even really care about what I see on my screen. I'm hitting my down arrow to see what I'm looking for. And you'll notice, even though it doesn't give you the range, it does give you your max and your min, so you can do your range from right there. So we have a quartile 1 of 142.5, a median 150, and a quartile 3 of 170. So I'll just come back on over to my sheet here and write that down so I can answer the question. Actually, I don't have it on my sheet, so I'm going to just write it here to make my life easier. So quartile 1, 142.5. Quartile 2, also known as the median, 150. Quartile 3, 170. And then the other calculation you need to do to answer this question is the IQR, the interquartile range, then is 170 minus 142.5, which is equal to 27.5. Okay, there you have it. That's all I want to talk about for now, just to kind of get us into the mood of statistics. So you should go on over to MathXL for Schools, and under the homework there's one called Stats Practice Number 1, just to kind of do a little bit of practice thinking about this.